Hello! This in-depth video tutorial will provide you with more details about the illumination sources of your microscope and its imaging modes. The system has multiple illumination sources for different imaging scenarios. Curved illumination is essential for imaging reflective and opaque samples from various angles. Spot illumination is used to apply higher intensity light to specific locations. Ring illumination with RGB white LEDs is particularly useful for imaging non-reflective samples. Close-up illumination, compatible with the high-zoom lens, applies high-intensity light to the sample from a very close distance. Finally, the coaxial light source is used to illuminate and image highly reflective samples directly from the top. Before we start, select the COM port from the top right corner, which will automatically update the parameters from the microscope. If you see a question mark, home that module by pressing its letter ID. Then, select the camera from the lower left corner to start the preview. You may also enable the scale bar by choosing a lens. We will now start by imaging a transparent sample in transmitted light mode. This is a transparent microfluidic chip. We fix it to the sample check and place the curved illumination underneath. In this mode, the light illuminates the sample from the bottom, and the camera collects the transmitted light from opposing angles. Because the camera captures images from negative angles, make sure to rotate the image in the software, otherwise it will appear upside down. You can view the sample directly from the top, similar to using a regular 2D microscope. However, the specialty of this microscope is that you can tilt the camera to visualize 3D structures, such as channels and protrusions. The curved illumination also allows you to toggle individual columns of the light matrix, illuminating the sample with different light patterns. During tilted imaging, we highly recommend using the provided aperture control diaphragm to control the depth of field. When you open the aperture, the depth of field is reduced, but the focused areas appear clearer due to the increased light. When the aperture is closed, more regions are in focus, but the reduced light results in a noisier image in auto exposure mode. In this case, consider manually increasing the exposure time from the camera settings. Alternatively, you can use automatic focus stacking, which we will explain in a minute. Transparent samples can also be imaged using the high zoom lens, referred to as lens 2. Note that this lens has a much shorter working distance than lens 1, so you need to move the camera very close to the sample. Remember to select lens 2 in the software for the scale bar, and you may need to adjust the white balance manually in the camera settings, as this lens does not have an infrared cutoff filter. For automatic focus stacking, which can be used with both lens 1 and lens 2, click on the focus stacking icon and follow the on-screen instructions. First, focus on the initial position, then the second, and the microscope will automatically take as many images as you specified in the settings and merge them into one image with complete focus. For better results, you may want to use third-party software, such as Helicon Focus, to merge the images. If your sample requires a higher intensity light source, you can use the spot illumination, which is already fixed to the base with a thumb screw. Unlike the curved illumination, which can illuminate the sample from a wide range of viewing angles, the spot illumination needs to be positioned manually for each camera angle. This light also has a retractable diffuser film, which can be removed to illuminate the sample directly from the LED to highlight different features. Now we will discuss imaging opaque and highly reflective samples, where the camera is tilted to positive viewing angles to collect the light reflected from the sample. Here is a highly reflective silicon wafer that we will use in this demo. Before changing the hardware configuration for this mode, move the microscope to its upright position by pressing the A and B buttons, which will home the tilting actuators. Alternatively, you can press the home button to initialize all actuators. Next, attach the curved illumination to the articulated arm using the thumb screws, as shown in the video. Place your sample using one of the provided chucks or your custom design and 3D printed sample holder. The next step is crucial. Unlike transparent samples discussed earlier, tilted imaging of reflective samples using the curved illumination always requires a minimum tilting angle. Begin with at least a 10-degree camera tilt, position the curved illumination, and then you can tilt the camera all the way to 90 degrees without needing to reposition the light. For example, here the light is initially not correctly positioned, resulting in darker areas on the sample. You can adjust the light source using the articulated arm until the entire sample is illuminated with diffused light, without being shadowed by the camera. Once again, we recommend using the aperture control diaphragm to manage the depth of field, or employing automatic focus stacking for sharper images, even at extreme viewing angles. The curved illumination can also be used with the high zoom lens. However, if you require more light intensity during high magnification imaging, you can utilize the provided close-up illumination. This light is compatible only with lens 2. Ensure that it is fully inserted without any gap between the lens and the light. Then, select lens 2 from the software if you need the scale bar and move the camera closer to the sample. Note that this light supports a narrow range of camera tilting angles depending on the reflectivity of your sample. You can then adjust the light intensity from the software, and, if necessary, flip the diffuser cover to illuminate the sample directly from the LEDs. This may highlight different regions of your sample, providing better contrast for defect detection. Now we will demonstrate a more recently developed coaxial illumination source used to image highly reflective samples directly from their top, similar to a regular stereo microscope. The coaxial light is equipped with RGB white LEDs that can be controlled via the software. Additionally, be aware that this light is compatible only with lens 1 due to its larger working distance compared to lens 2. Please note that all light sources shown in this video can be connected to any available cable, so there is no specific cable assignment. In summary, transparent samples can be imaged from any angle using the curved illumination without limitations. However, reflective samples require the coaxial illumination for viewing angles up to 10 degrees, and the curved illumination for higher angles. Multiple lights can also be used together. For instance, consider a transparent microfluidic chip with metal electrodes. Here, we can illuminate the microfluidic channels with bottom illumination and the electrodes using top coaxial illumination. By adjusting the relative intensities of the light sources and the color of the coaxial illumination, you can highlight different materials on the sample. Now, we will review the ring illumination, primarily used to image opaque but non-reflective samples, such as printed circuit boards, electronic components, and some 3D printed or mechanical parts. Individual LEDs of this illumination can be toggled, and their color can be adjusted from the software. For example, let's consider imaging an electronic board while rotating and tilting it. You can enter the relative mode in the stage control, set a rotation angle and speed, and do the same for tilting. Then, press the arrows to initiate automatic movement of the actuators. You can, for instance, utilize the ring illumination along with the curved illumination to highlight different features of the sample. Please remember that every sample is different, and the most optimal imaging conditions may require a different combination of light sources specific to your sample. Finally, the microscope is equipped with a third wide-angle lens, suitable for imaging larger samples, such as full wafers or circuit boards, with dimensions of 10 centimeters or larger. However, please note that this lens does not support scale bar or measurement annotations. For wide-angle imaging, the light sources demonstrated in this video may not be sufficient to illuminate the entire sample. In such cases, you may want to consider using soft lights commonly used in standard photography applications, light boxes, or large LED panels, which are readily available in many online shops or photography stores. Also, please note that the microscope can be expanded to accommodate large samples using 3D printed adapters. While these adapters are not provided with the system, you can either 3D print them yourself or request them from us. We hope you found this tutorial interesting. Remember, finding the optimal illumination is one of the most important steps in microscopy. We are happy to support you with your applications and design new modules for your specific needs, such as this UV ring illumination with an integrated filter. Please do not hesitate to contact us. Thank you, and goodbye.